And my voice is also audible.
Your voice is also updated.
I think
Yeah.
you people are having a very good microphone. It will sense a small air or small disturbance came. So I'm very
So,
happy on that. You people are listening well that much. So this is we needed for from your side. Okay, actually the fan is turned on. I have turned off for you. Okay, now we are going to enter into the data type in C. It is very, very mandatory. We are writing the structure of C. We have followed the structure, documentation section, preprocessor section, then main section, and that we have a two section. One is declaration section. So this data type in C, it's are very much important while I am declaring any variable. So at that time, this data types in C are usual. Okay, so while we are seeing with that processor section and all, preprocessor section and all, we have to include the standard files and all. But when you go for declaration, what are the types of declarations are available now? Data types. What are the data types now? These are the three data types. You just note it down. Not all the types. You just note down the three important division: primary data type, DT refers data type, user defined data type, and derived data type. Are you clear? In primary data type, just mention char, float, int, void. Okay, because that we will see one by one separately. So just you make note of it. Char mainly for the characters. If I want to represent any characters, I will use the data type, and this is one of the keyword also, char. Even you did a mistake in the, while writing the char, automatically my compiler will throw the error message. Okay, float, it is mainly for the decimal point. We are used to use the float data type. Integer, it is purely integer value only, I will use int. And you all know, all are, we are said one important point we said to that, C is a case sensitive. So float, int, void. Okay, this is all four. You just write down the signed and unsigned, you need not write. While we move on to that type, we will see. Then user data type, enum, type def. Okay, and derived data type, pointers, arrays, structures, union. Okay, so I think we will elaborately see this pointers in the third unit and array structures union in the second unit, but we will see what is what. That's it. Okay, so these are the data types in C. Why data type in C are very, very important now? How much space it occupies in storage, that's very important, because we all know all our are very concerned to the memory. So how much space it occupies, how much storage is needed, it's very important. So for that, we were all moving with this data type in C. Okay, now I will I think you people have noted down this alone. I think I will move on to the next slide. Recording clipping, you just wait, ma. We will ask and we will tell you. Okay, I think Monday I will tell you. Okay, first I will teach the basic concepts, and then I will move on to the second slide. Okay, so you all know what is bits, ma? In binary, what is bits? We used to say 0 and 1. This is my binary. Yes, yeah. I'm getting the answer. Very good, very good. So after that, you all know byte. We use the word byte. What is byte, ma? Group of 8 bits. Group of 8 bits. Okay. Okay. Group of 8 bits. And here we will represent the data type by bytes only: 1, 2 byte, 4 byte, 6 byte, 8 byte. How it will occupy, that's very, very important. Okay, we all know the decimal number, how we are representing in a binary. When you take, okay, 255 in decimal na, the value will be maximum 1 1 1 1 1 1 1 1. So how many byte it is, ma? 1 byte, because we have 8 bits are there. Am I correct or not? 8 bits are there. So that will be byte. And you all know 2 byte is word. Okay. But you have to remember why I am teaching that now. In previous slide, just we represent the value. Okay. And we used to say unsigned and signed. Unsigned and signed. Okay. For example, my value is 0 to 255. Okay. Sorry, actually 255 it's not there, and a signed number. It's from negative minus 127 to 128. Okay. So you all understand that actually 127 only the value we will put. Okay. So depending upon the one only, we will say how much space it is occupying and all. We will define to that way. So you all understand that whether it is a 2 byte or 1 byte, very simple how you will convert the decimal number now. For example, if I'm taking 12, okay, I want to convert that into binary now. You all know 2. If I divide, what is the value? 6, 0. Once again, if I divide, what is the value? 3, 0. Once again, if I divide, I have tried the remainder value here. Okay, 2, 1, 1. And I will write my value. My value of 12 decimal is in binary, the value is 1100. This is the way you will study this particular topic in a digital logic circuits. Yes, or else in physics also you will study. It's clear. But if it is minus 12, you all know we have a positive number as well as negative number. Minus now, the value is same 1100 only for 12. But this for negative, they will put 1 here, because to understand that it is a negative number. So why I am saying this now, the next previous slide, we are just going to see with the number and range. The number and range they were fixing now, they will convert that binary decimal number into binary. That much of byte will be occupied by the each data type. Are you clear? So one thing you understand, 1 byte equal to how many bits? 8 bits. 2 byte na 16 bits. Okay. Similarly, 4 bytes na 4 into 8, what we used to say, 32 bits. So this is the way we will just correlate the byte with bits. That much of bits it will allocate. And we all used to say nowadays, while I'm purchasing any phone and all, we used to say first it is how much capacity. Now we were moved from kilobyte to megabyte to gigabyte to terabyte and all. So that we will see what is the capacity of that RAM and we used to buy. So bytes is very, very important for the memory allocation for the storage variables. So now I will move on to my previous slide. Okay, so you please kindly note down this. Just note down these two values alone. Range, you believe it, because you all know my integer can hold how much of data na? Nearly the number starts from 2 billion. 2 billion number it can store. But when you see with that, we have a two type in integer. Okay, one is unsigned integer number and another one is signed integer number. This is the way I will differentiate unsigned and signed. I told you already, signed na negative number and positive number should be there. Okay, unsigned na it hold only the positive number. That is the way you have to differentiate unsigned and signed. And you all see why they have written two probability 2 or 4 bytes now. It mainly depends on the system. While you are seeing that, you check with your system whether you are using 32-bit system or 64-bit system. According to that, the integer size will also vary. Okay, I will show you a small program demo now, how to identify the your system's configuration. Okay, now you just write down this two alone. I told you this two alone. So integer na 2 or 4 bytes. You all understand. Unsigned is also my keyword. For signed, I never put signed int. I will just, you all seen, all are in small letters. Even if you put capital letter, it will show the error. So you all know C is a procedural language, structured language. It is has to follow the keyword. So your keyword should be a case sensitive and it should be in a lower case only. So int now I have to use int. Okay, and short, you are seeing int, short, long. This all comes under the signed data type of integer. Okay, and I move on with this. Okay. Okay, and this unsigned integer, unsigned short, unsigned long. Okay, this all consisting of positive. So signed and unsigned both having 3 category. One is short integer, and another one is integer, and next one is long integer. First you learn this alone. Are you clear or not? You just learn int 2 or 4 bytes. You all know 2 bytes now how many bits it will occupy? 16 bits. Okay, 4 bytes na 32 bits it will occupy. Similarly, you have seen short will occupy only 2 bytes. Integer, actually when you see almost our systems are upgraded, so we are getting only 4 bytes only. Okay, we will check with the program. Long, it will occupy 8 bytes. And sometime we used to say long int also there, but it is also maximum occupy 8 bytes. So you have seen short is 2 bytes, int is 4 bytes, long integer is 8 bytes. This thing you have to remember. Is clear? Short means it will occupy 2 bytes. Integer means 4 bytes. Long integer means 8 bytes. Yeah. I think the screen is visible, ma?
Yes, ma'am. Yes, ma'am. It is visible, ma'am. Screen is visible.
Yeah, you all understand that unit 1 course material, half of the unit course material, we put it in LMS, that is in PDF format. Once we complete this topics, parallelly we will add it. Okay, next week I will add the first part of the unit. Okay, unit PPT. So now you can refer unit 1 course material, which is put up in the LMS. So you people can refer it. Okay. Yeah. I think you just note down this int, unsigned int, short, unsigned short, long, unsigned long. So you have understand that integer will occupy maximum of 4 bytes, short will occupy maximum of 2 bytes, and long will occupy maximum of 8 bytes. Okay. Okay. And now I come into the format specifier. Most of them have this doubt. What is format specifier? While completing this topic itself, you have so much of doubt. Okay. So you all understand. First, I think you format specifier you have tried. For integer, it is percentage %d, and frequently we were using, and this is one of the very important format specifier. Why I am putting percentage %d now? I am repeating, C is a structured language, programming language. We are supposed to specify the format specifier, and in format specifier no numerals will be allowed, only it will allow only the letters. Okay, percentage %d. Okay, then short integer, I'm putting short integer percentage %hd. You just mention it. Percentage %hd. Long integer percentage %ld. This I have written for signed integer, signed short integer, signed long integer. So integer na percentage %d is percentage %d, comma short integer na percentage HD. Okay, long integer na percentage LD. L represents long integer. Okay, so you all have note down this format specifier we frequently use. You all know the value they given minus 32,000 and it having. When I add this two value 32,768, 32,768 plus 32,767, what I will get now? 65,535. Okay, that's why there is no difference between the space occupied by short integer and unsigned order. So 65,535 is given here. And you all understand that unsigned na they use the symbol U. Okay, and almost now it's very simple for us, but U will be used. Okay, you just note down the format specifier alone. Format specifier alone for all the data type. You just refer long. This is nothing but L. Don't get confused. It's not one. It is long only. Okay, you just write down the format specifier. Range limit, it's not needed for us because you have to know only the data type, the size occupied. You all know the size is in bytes, 2 bytes, 4 bytes. They were saying now. Actually, I put 2 or 4 bytes. Why? Because na, some of the system will show. But you all understand integer will 4 bytes, short will 2 bytes, long will 4 bytes, and long will be 8 bytes. Okay, but it all depends on system only. I'm saying it all depends on system. But previously I have shown now the range I have shown now. That's why there I have asked you to copy the bytes, and here you copy the format specifier. Format specifier, 3 format specifiers are very important. Percentage D, it's very important. Percentage HD for short integer and percentage LD for long integer. If it is unsigned, what I have to use? Percentage LU I have to use. Percentage LLD, percentage LLU. You have seen? Because these are all about the long. That's why they have put up. I think, have you taken this, mom? All this will be shared to you. Don't worry, all PPT, everything will be shared to you. So now you just note down very important things are integer percentage D, short integer percentage HD, and long integer percentage LD. It's all about signed. Unsigned na, instead of D you have to put U. That is the only difference. Instead of percentage HD you have to put percentage U. Then instead of a percentage D you have to put, replace all D by U. That is nothing but your uh, unsigned and signed integer difference. Instead of D, I have to put U. Instead of D, I have to put U. Is all clear, ma? What is range limit, ma? Why? Okay, I will tell you that while I want to convert this 65,000 and 65,535, I'm saying na 65,535 in decimal. This is in decimal or it's an integer value. If I convert into binary, how many bytes it is occupying? 2 bytes it's occupying. 2 bytes it is occupying now almost 16 bits. It will occupying how many bits? 16 bits. So once I convert my binary values 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1. So totally I will get 16 bits here. This is the way they were fixing, and I can use maximum 65,535, the value they were saying. Okay, but anyway, you may ask, what is my negative value? I have already told you now, 1200 is my positive number now. The value is 1100. And if it is minus 12 now, it will occupy that again one negative number. Similarly, if I put negative and positive, my bits will be increased. That's why while adding this two number, I will get this 65,535. That's why it is occupying 2 bytes. When I am taking integer, this value I am taking now, this will occupy 4 bytes. 4 bytes means when I convert this decimal into binary, nearly 32 bits will be there. Triple E lesser, easy. So nearly I'm occupying 32 bits here. Are you clear? Yes, your doubt have been resolved. Yeah, you have to learn only the data type and mainly for programming it will be used. Okay. Now I will go to the online GDP compiler. I think you may also have parallelly, you have a online GDP compiler. I will put you the program. I will share my screen. I think online GDP compiler, how you have to search now. I will tell you, whoever is new today's class, go to Google and type online GDP compiler. It's become very easy for you to do and execute the program, and instead of Turbo C, it is very easy for us to do the program for you. Okay. So online GDP compiler, you just put it and you search it, you will get it here. Once you do, you just hide it. And here you have option of editor theme, dark will be there. You choose light, it will be pleasant to our eyes. And then you delete whatever given there. And you select our language is C language. Code blocks and all, we will wait, we will enter into the state control statements, we will see that. Now we were seeing only about the data type. Okay, so here I'm just going to check my integer, short int, long int, long int. Are you clear? I'm just going to, I'm declaring my variable. You see, I didn't put the documentation and it's optional only to check data type, data type, data type in C. This is my documentation section, and I have included my preprocessor section. This is my preprocessor section. Okay. After writing preprocessor section, you are supposed to write the main section. Okay, I put int main. Why? Because now here I'm not returning any variable, or else I have to put void main. And these are all about declaration section. First, I will enter the declaration section. I think you have to know while you are writing. The next one is, it's nothing but our execution section. X. Okay. So you all understand int A. Hariharan, while you are stop your videos. Why? Because now if you sit and listening, you turn on your videos. Don't move here and there. Once you turn on your videos, you all understand it will be pop up in my window. So who are all turning on your videos, I can easily, you are listening and you sit and you don't have any problem and all, like that network buffering problem and all, you can turn on your video and sit. But or else you turn on your cameras here and there, don't do that. Okay, so this is execution section. Size of integer. Okay, I just printf statements. While we are explaining that, we have two statements, scanf and printf. Scanf for giving the read the input from the keyboard, and printf is mainly to print the value. So we will teach this particular syntax in IO functions. So you just note down what we are going to see now. We are supposed to see about the okay, we are supposed to see about only the size of the print. So what is the syntax I have used now? Size of. This is one of the important keyword in, you will study in C tokens. Size of. You may write at least for only one printf statement. One printf statement you just write down. This is size of, it will print. Percentage D, you hear your what you have to note down now. Percentage D I have used for integer, and percentage HD I have used for short integer. Percentage LD I have used for long integer. Percentage LLD I have used for long integer. Only difference is my value will be starts from 65,000 to some billion value my integer data type can hold. You all know, while in calculator it will maximum accommodate around 32 bits. It goes beyond that, it will show that the bit has been truncated and all. That's why this particular data types, it will allocate or it will carry its own value. If the value will be higher than that, then automatically it will be truncated. Okay, so I have put size of A, that is integer, size of B, that is short integer, size of C, that is long integer, size of D, that is long integer. Okay. Yeah, no, we should not return 0. You should not use getch, because getch I am using now, that particular character will be read from the keyboard, so that I have to use void main. And one more thing, this online GDP compiler, it doesn't supports the conio.h function. That's why we are not using that value. Are you clear or not? This online, it's not supporting, that's why I'm not putting. Are you clear, ma? And don't think that this particular topic is not available in PDF. PDF is a course material we prepared, but PPT we then and then while taking class we will prepare. So you don't worry, we will put up that PPT also for you. Okay. And now you run the program. You may study the remaining topics. Okay. You just see size of integer is how many bytes. I put percentage D na 4 bytes. Size of short percentage HD 2 bytes. Size of long 8 bytes. Size of long 8 bytes. So almost long and long there is no difference. Both will hold only 8 bytes. Okay. Are you all clear, ma? Are you all clear? Why there is long and again long integer? Okay, actually you all seen some of the data type, only the number value it can handle 2 power 30 na, it will. I will show you while I'm comes to the PPT. Okay, we have showed the range now. Why we are splitting into integer, short integer, long integer and all na? Only the data which can handle by the particular data type. Okay, and now I will just put to find out unsigned. So use the keyword unsigned. Okay. Before all that, unsigned and another unsigned. Unsigned. Okay. For signed, it's not mandatory. And you all know I replace all D by U. Okay. It's very simple for you to remember. That's why I'm saying. Okay. Now I will execute my program. You see, size of integer is 4 bytes. Size of short is 2 bytes. You all know it will hold only positive number value. When you go for signed, it will hold both negative and positive value. You just take down the snapshot if you want, or else we will share it in PPT. Yes, clear? Okay. Can you all understand this, ma'am? Yes, we all understand what I did now? To differentiate that, I just put unsigned and I have replaced all percentage D by percentage U. Wherever D is there, very simple. You all understand. One thing you understand, I will just note down integer. I think whoever not written, you kindly write integer percentage D. Okay, this is signed and this is unsigned. Integer na percentage U. Short data type na percentage HD. And here percentage HU. Long na percentage LD and percentage LU. Long. I will tell you the data limit one of you have asked. Percentage LLD and percentage LLU. That's it. Okay, just you put it like this, then it is easy for you to remember. Are you all clear, ma? Yes? Okay. Okay. So you now the same output only I have shown you. Okay. The next data type is char data type. It's very simple for you. Char data type. It's nothing but it will hold only a single character. That's very, very important. The next you write char data type and you just write down this alone. I think, sorry, one of you have asked that out. Then I will come back. One of you have asked, ma'am, why long? Yeah, you just see. One of you have asked long integer and long integer. Actually, in this particular system, long and long both are holding 8 bytes only. We executed, but you see that long na this much of number it will hold, and long na it will hold 2 power 63. That is the only thing. Much value. Okay, we were started from 1,000 values to some billion value we are holding. So billion number. I used to say now, how we used to say, do 2 billion, 14 crores, 74 lakhs, 83,000 and 648. This is the way we will tell it in number system. This is the way here also we were saying. Is clear, ma'am? Okay. Okay. I think one of you have asked. That's why I have come back. Char data type. You just note down this, ma. Char means it called a single character. Okay. But in similarly, char, what is the maximum byte now? 1 byte. Very simple. Why it is 1 byte now? 255. I have written there now. 255. When you convert into decimal, automatically when you see that, uh, the value will be, when you divide and do, you all know I'm putting 1 means it's a reminder. Sorry, this is 31. Okay. 15. 7. 7 twos are 14. Reminder 1. 3 twos are 6. Okay. So you just see we are getting 8 ones are there. Okay, that 8 1 means what? 255. 1, 2, 3, 4, 5, 6, 7, 8. 8 ones are there. So 255 means maximum. When I convert into binary, my value is 1, 1, 1, 1, 1, 1, 1. So totally how many byte? 8 bits, 1 byte. And if it is a unsigned number, okay, unsigned number, this is my value. I told you already, if I add minus 128 plus 127, I will definitely get what number, ma? 255. Okay, that's why we split it. But what is the format specifier? Na percentage %. So you just see how they are declaring the signed char name. You all know we can use signed also, but without signed also I can put char name. Okay, and for unsigned it is mandatory. We will execute in both the ways. Okay, char name. You all know it hold only a single character. That is the only thing, char name. You just take down this tabular column alone. I think you just take down this tabular column alone. So char na, what is the format specifier? Percentage %C. Integer percentage %D. Even though you wake up from your sleep, you have to know for integer percentage %D and for char percentage %C. There should not be any confusion. Range limit is not mandatory. The byte as well as format specifier. That's true, very important. Is clear? Are you all clear, ma? Okay. I think you people have taken. Yeah, it is not there in character we used to say in the way how we will say na a b c d f and special characters, which is you have seen in your keyboards and all. So that's why maximum it will take the percentage %C only. That is the format specifier, because it's called only a single character. It's not by a value. We all see all are 1 byte only. All are 1 byte only, but integer it's not like that. Integer 4 byte short, 2 byte long, 8 byte, that will be different. So format specifier is also different, but for char all are 1 byte. That's why there is no difference like integer. Yes, have you taken this, ma? Have you taken? Yeah, this topic is not there in the PDF. Okay, it will be in the second part. Okay, I will check it. Okay, today I will put this and data type. Don't worry. I will upload a PDF and you can study it in your Gandhi Jayanti. Okay. The next one is float data type. Another important one. Float data type for mainly fractional numbers and with digit of precision that is available. But while we are checking with that maximum it can hold, it will float means 6 decimal places it will hold. After the decimal it will hold. Double na 15 decimal places it will hold. Long double na 19 decimal it will hold. You just imagine float data type, the format is where here can you able to see percentage f, percentage small lf and percentage capital lf. Float percentage f, you all understand, integer percentage d, character percentage d, and float percentage f. If it is a double, percentage lf, percentage lf. Long double, that means percentage capital LF. L is capital. That's the only thing. Floating point is denoted by the fractional numbers. So what is the difference in range is also different, but don't take the range. You take only the precision. Data type, size, and precision alone you take, and format specifier. Are you clear? I think I will clear all my drawings. It will become very easy for you to write. You just write data type, size, precision, and format specifier. So float na 4 byte percentage f, double na 8 byte percentage lf, long double na 10 byte percentage. So you all imagine 4 byte na how many bytes? Only 32 bytes. You all know 8 byte na 64 bits. 10 byte na automatically 80 bits it will cap. So comparing with that, long double is the highest bits which is stored in the data type because it have holding nearly 10 byte, and you all know that format specifier. Valid size for float. Valid size means obviously float now 4 byte now, 4 byte only. For float it is mandatorily 4 byte with 6 decimal precision. You all know 1.2, 3, 4, 5, 6, 7. This is nothing but 6 digit of precision. When I go for 8 digit of precision, 2, 3, 4, 5, 6, 7, 8, 9. This is almost 8 digit precision. This is 10 digit precision. Is clear? Oh, you are unable to see the percentage. Huh? I will put it here. Percentage F double, percentage LF, and long double, percentage capital LF. Are you all clear? Is clear, ma? E is exponential, E power, E power 38, E power minus, that is the way they were representing. For example, you all write now 1.3 into 10 power minus 3 I am writing now. In calculator and all, we use the 1.3 into E power minus 3. Both will be same one. Signed means, I told you that signed means both negative and positive number will be there. Unsigned na, there will be no negative number. It hold only the positive number. Is clear? Care and signed care. Signed care, actually signed way they won't put, you have to ask care and unsigned care. Shigari, have you understand the difference? Care and, because if I default put care na, that automatically takes signed. If I put unsigned only, it will take. Okay, so care and signed care are same only, but care and unsigned care are different. Care means we have shown previous slide. That is nothing but it will hold. I think, have you taken this? Yeah. We all know it is a 1 byte. Both will be same. Okay, I told you that I can put char as well as signed char. Both will be same, but only difference is unsigned char. It hold both positive and negative number. It hold only the positive number. Okay, I think we see one small program. Okay, we are supposed to complete the topic. Okay, you just see I have put one integer int a equal to 1 and char and one double number. That's why I put, if I put unsigned char, that's okay. Or signed char, that is also, both will be same. So int char double, you all understand that? So what I am printing now, hello, I am a character. My value is percentage %C. Percentage %C means what, ma? What percentage %C is which data specifier? Percentage %C is for what? Yeah, character. Very good, very good. Then percentage %D for? Percentage %D for? Int. Yeah, thank you, thank you. And when you go with percentage %LF, yeah, long float. Actually, you all understand it is almost, it will be same only to that what I will put. Yeah. Long float. Actually, while you refer your previous slide, what I showed to you, float, double, long double. Okay, float, what I put, float percentage F, double percentage LF, long double only capital LF. So this is nothing but double only. Okay. So now hello, I am a character, my value. This will print the character. This will print the integer. This will print the double. Okay. Then my size, I am saying now percentage D. Why I am saying percentage D now? We all know if I want to print any integer value, I have to use percentage D only. So size of the character. First it will print the size of the character. What is the size of the character, ma? What is the size of the character? 1 byte. Yeah, very good, very good, very good, Amma. And the size of the integer? Size of the integer. Already we have shown previously. Size of the integer, it's not 2, 4 bytes. In our system, what is here you are seeing? Size of integer is 4 bytes. Okay, don't put 4. 4 byte is correct. Okay. Then size of double? Size of double? 8 byte, B-Y-T-E. Okay, byte. Okay. Okay. Now I will execute this program. You all see, I am a character. It's printing, hello, I am a character. My value is percentage Z. What is in that C? G is there because it covered only a single character. My value is G and my size is 1 byte. Okay, next. Hello, I am an integer. My value is, what is the integer value I hold? 1. But you all know the maximum value I can hold will be 65,000. There we have seen that value. I can hold it, I can print it. Okay, you just wait. I can, my size is 4 bytes. And hello, I am a double floating point variable. My value is, okay, you all know, all here I told you, the very they have so shown you 6 decimal precision, 8 decimal precision and 10 decimal precision, but the system is taking maximum, it's all the system dependent. Here it is taking only a 6 decimal precision only. And the size of my double is 8 bytes. So size of, one thing you understand, size of the character is 1 byte, size of the integer is 4 byte, and size of the floating point, that is double, is 8 byte. So instead of double, if I am putting float, I am changing because this is 4 we used to use frequently. Integer, char, float. This we used to, you see, float. Okay. Now instead of this LF, I have to put F. Okay. Now if I run the program, here's you see. No, it's not a double. It is a floating point variable. My value is percentage F. Okay. But you see, Normally float will occupy how many bytes, ma? 4 bytes, but my system is showing 8 bytes. So it's all system dependent, but you all understand one thing very well. My thing, I have to see character na percentage C, integer na percentage D, float na percentage F. That doesn't vary. This will always hold 1 byte data, and this percentage D always hold 4 byte data, and this percentage F is also 4 or 8 byte data. It's all dependent, system dependent. Okay. Yeah. So the next one is about void. You are using void na. So void has no value. Okay. If I want to return any value, I won't return any value. So void means null. So where we will specify this void na, mainly with the main function. It is mainly to specify functions also it does it. But void does not return any value. So we cannot declare it is as a variable. For void means null. Int mains means it will return integer variable. Float main na float variable it will. Double main na it will return the double variable. But void main na it does not return value. Void na null, nothing. That is void. It's clear. It's very simple. But how we will write the syntax of void na? Void. It's my keyword. Void is my keyword, and my void along with main function I will use, and some of the functions concept also I will use void. So void main example, very big example is void main. Okay, next important is we have 3 data types. I think while move on to our first unit, primary data type, user defined, derived data type. So now we will see derived data type. I think derived data type we will see elaborately in the second and third unit, but I will tell you what is that. Okay, mainly array. Okay, what is array? If I want to store a collection of data with homogeneous data, that means similar data type, okay, collection of data with similar data stored in contiguous memory location, continuous memory location, that is array. If I want to store collection of data, what is best example now? When I want to store your mark. Okay, so you all know all mark are in integer. Actually, while I'm saying this, I become because now the 12th result where we got in Tamil Nadu, I'm not about others, other states. They have with decimal precision, they have released the result. So we used to say the result is always will be in integer form. Okay, so I will say to that array, it's nothing but collection of data. For example, your mark is 100 and 90, 80, 70 and all means all are similar data type. Okay, that's one condition. And collection of data, that is another condition. And I want to store in the continuous memory location. At that time, I will go with array concept. So array means collection of data and with homogeneous data, similar data type stored in contiguous memory location. I think this will be the definition. This will be the definition. Array means this will be the definition. Okay. Array also referred as a structured data type. What is the key variable I have to use for array na? Int. Integer data type na int. Okay. Then ARR1. Okay. This is my variable name. This is my variable name. How we have stored int A, int B, int C we have told na. This is my variable name. Okay. And how many data I'm going to store? See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 data. Okay. The length of the data. So how many memory location it will occupy, ma? Can anyone tell? This particular array will occupy how many? This particular statement will occupy how many length? How much of bytes? Sorry. How much of bytes? Yeah, I got one single answer. 4 byte. No, not 10. No. 8, 9. Hey, someone. For only one of you put. Oh my God, I have to stop. It is very difficult for me to, because getting. Wait. One of you have put the Priti Pratap have put the correct answer. That is 40 bytes. It's correct. Why? Because integer na. What is the size? Character 1 byte, integer 4 byte. Float is also maximum 4 bytes. Some of the system only showing 8 bytes and all, and it's all depends on online GDP compiler. But you all understand integer 4 byte, character 1 byte, float 4 or 8 bytes. It's clear. But here I told you integer. So this will occupy how many bytes? 4 byte. This will occupy 4 byte. So how many datas are there? 10 datas are there. So 10 into 4, 40 bytes are there. Are you clear? So the memory occupied will be 40 bytes. The memory occupied will be 40. Yeah, 42 and all. How come? 40 bytes only it will store, because 10 into my integer is 4 bytes. So 40 bytes of memory is wasted to store the data. 40 bytes. 40 bytes now how many bits? 40 bytes now how many bits? Yeah, 320. Again, Priti Pratap. 320 bits. 320 bits. Are you clear? Okay. So now the next one is pointer. Okay. Pointer is mainly, we were saying it's a powerful feature in the C. Why? Because now we can access the memory through address. Very simple. When you are in apartment, when I'm specifying the whole thing, instead of that, you are in one home, you have a unique address for your home, then automatically the postal will be delivered. The same way here we will access only through the address. So automatically depends on the variable it will allocate. So pointer car. So you all see, this is my header section, so preprocessor section, and this is my that. You all know int I equal to 10. I have declared. Okay, int asterisk j. Asterisk is nothing but integer point. This we will study separately, but here you have to know only that this is the definition for the pointer. It provide user an ability to access the memory and address of the variable. Okay, so asterisk that we are using, say asterisk, and then that is the pointer, integer pointer variable, and j equal to, I will specify ampersand of I. That is why address. I can access the variable through the address, memory and address of the variable. That is pointer. So you have to understand that the pointer variable asterisk we are using. To access the address, we are using ampersand. So this is the example for the pointer variable. Is clear? So through that, what is main advantage na? We can able to only access the address na. Most of the time the memory will not be wasted. Sometime I will put integer array of 10 or 20, but I will allocate only 10 variable in my program na. The remaining 80 bytes will be wasted. That is overcome in the pointer. For example, the best example is if I am putting int a of 100. That means my array size, I am saying 100. You all imagine 100 now, how many bytes? 400 bytes allocated. But in my program, I am using only the variable as only 4 variable or 5 variable. So 20 bytes only I am going to use. Remaining all bytes are get wasted. That will be avoided in the pointer. Mainly for the memory management purpose, we will use pointer. So we are all studying about the what data type we were seeing now. What data type? Pointer concept. Okay, so you all understand. I'm declaring the variable. I want to access the variable through this j now. This is nothing but asterisk j. Asterisk j, if I put, automatically it's a integer pointer. How we will say int is nothing but a data type of variable. Similarly, asterisk the pointer variable. So I'm putting asterisk j. If I put asterisk j, I can able to access the address of I. That is the only powerful in pointer. So if I put asterisk J, I can access the address of J. So J equal to what I can simply put now, ampersand of I. That is possible here. Yes, derived data type. Yeah, yeah. Thank you, thank you. Oh my God. Okay. Then the two more data type, structure and union. Okay, actually we will briefly study about structure and union, but what is the difference in array that will be overcome in struct? What is because now struct can hold relative of different data types together. In while we are seeing array, it will hold int array, it will collection of similar data type in the contiguous memory location, but structure can hold relatively different data type. You just see what is the important keyword for structure na, struct. Okay, this is my tag name, student is my tag name. For example, I can create it for struct employee, that means employee detail. You all understand? Care, how many bytes it is occupied now? Tell me. Care, how many bytes? You take float as 8 bytes. Point, yeah, 1 byte. Pointer, I told you that is enough. What I gave the definition. Pointer is nothing but it's used to access the address of the variable. Okay, so pointer variable, I will mention asterisk. Asterisk is nothing but pointer variable. Okay, and through J is pointer variable now, I can directly access. Address means I will use the symbol ampersand. So mainly for memory management purpose. Okay. Integer, how many byte ma? How many byte? 4 byte. Okay. We will take char as a 1 byte, integer as a 4 byte, and we will follow this system. Okay. Because I will take only in the system. Float as 8 byte. Okay. So totally how many bytes are have been allocated for this 1 plus 4, 5, 13 bytes have been allocated. Yes, clear? So we all know char means we will put percentage C, integer, sorry, it's not that 10 na 10 bytes, sorry, 10 plus 4 14 plus 8 22 bytes, I'm sorry, 22 bytes. Yeah, yeah, 22 bytes actually. Why 10 ma? Char is 1 byte, but char name of 10, they were saying that my maximum length of the name is 10. But you all know most of the name are having 40 characters and all. At that time we will hold. But this program, 10 bytes for character, integer 4 byte, float 8 byte. So totally, what is the how many byte it is allocated? 22 bytes. Okay, this is structure. Okay, then what is union? Only difference by looking that struct I am using, here I am using union. That is the thing. But you all know what is the integer data type variable ma? 4 bytes it will allocate. And it will allocate 8 bytes. And long double will occupy how many bytes? Long double, 10 bytes. Yeah, Bhargavi, good. 10 bytes. So here what it will do now, totally how many bytes of memory is needed for my structure concept? 22 bytes. But here it will see which is having the maximum size. Long double now. So it will allocate only 10 bytes. So union stores different data type in the same memory location. Okay, it will totally allocate 10 bytes. There overlapping will happen. That is one of the disadvantage. But you see, same structure, I require 22 bytes. I require some 22 bytes here. 22 bytes is required. But when you go with this, I require only 10 bytes. But you just understand that structure and union can hold different data type. Structure, I will use the keyword struct. Okay. And union, I will use the keyword union. Are you clear? And then struct, the tag name is student. I just use a character, integer, float. But union similarly integer, float, long, and it all can also handle char also. Okay, don't think that it can hold all different data type. But you see here it is allocated 10 bytes, it is allocated 4 byte, and it is allocating 8 byte. So 10 plus 4, 14 plus 8, 22 bytes will be allocated. But it will see which is having a maximum number of bytes that will be allowed in the here. So this are mainly and according to the data type only we are classifying, because while we are seeing the array will carry the continuous collection of homogeneous data, collection of similar data type in a continuous memory location. Pointer means it can able to access the address of the variable, and when you go to the structure it can handle different data type, and according to the data type it will allocate the memory for that data type. Union means it is also can able to handle different data type, but different data type, now what is the advantage? Now it will check which data type hold the highest memory space, that will be assigned to the particular tag name, and there it will be an assigned the same memory location will be shared by other data type. That is nothing but the union. Okay, I think the one more data type is left out. Yeah, time over. It is mandatory to that the size of all elements in. Yeah, it's not a mandatory. Okay. So it's our own duty whether the class is completed. We will inform you that class will be completed, because you all know you have a continuous session, and only the staff will be overlapped, and we will be changed. So we know we are looking on to that. Okay, 38 pages notes in book in ma'am of unit 1. Okay, unit 1 you told na, most of you were told that not covered. You just refer the course material. Next week we will put up the part 1. Okay, I think ma'am have any other ma'am joined?
We both are only available.
Yeah, we both are available. You're saying time up. How come? We are supposed to handle the classes for you.